This is a tutorial for WebMeV, a cloud-based platform for
The cost of sequencing has been dropping since 2008 with the emergence of next-generation sequencing. Good examples of a large gene expression database is a GEO database, which allows scientists to deposit their gene expression data from their own studies. The database currently contains expression of more than 1 million samples. Another example is the Cancer Genome Atlas project, also known as TCGA, which systematically collects an array of different genomic data from more than 20 different cancer types. A few hundred patients were collected for each individual cancer type. The original WebMeV is a standalone application for genomic analysis and is a Java-based standalone application that require users to download. While the standalone WebMeV still have allowed users, it required to download datasets onto local machines for analysis. The computing power does not scale with the size of the datasets. It requires maintenance and testing on multiple operation systems, and the applications rely heavily on user computing environments, and the developer have limited control over application dependency. Furthermore, it has really slow development cycle. The WebMeV is designed to have the application server to co-localize with tools and visualization applications as well as the public domain datasets on the cloud. And the aim for these applications is to use as an interface to the wide array of tools available in the bioconductor and through other open source projects. Should natively integrate large genomic datasets, and it should support the emergence of next-generation sequencing technology. The design principle that we follow is that we will adapt solely on open-source software technologies, adapt elastic computing for variable data analysis complexity, and application portability. Some of the use cases that we will support are how my favorite genes vary in the dataset from this paper. How are the phenotypes associated with the differentially expressed genes? How do other people I trust interpret this data I analyzed? The WebMeV beta version is currently available online at mev.tm4.org. The dataset loading page allows the user to upload data from their local drive, curated TCGA data, Google Drive, and the GEO database. The user can search a GEO database directly from WebMeV for gene expression studies of their interest by using either keywords or a GSE number to import the dataset into WebMeV for analysis and visualization. Once the user pulls in the data, they can filter using OpenRefine functionalities to be able to numerical facet on the clinical attributes of TCGA, or use the text facet functionalities to be able to filter the data to analyze for selected cohort, to search by self-defined facets, build composite phenotypes, and build cohort sets of interest. The user can also use the same functionalities to filter out genes based on their gene ontology and annotation. Once the dataset is loaded, the WebMeV main page displays the heat map of the data with the analysis result panel and the analysis method panels on the left. Once the user performs hierarchical clustering analysis, the user will be able to select and save samples from individual branches into sets. With multiple sets defined, WebMeV provides users with the ability to perform set operations such as merge, intersect, and difference between sets. With simple sets defined, the user can perform a wide array of analysis methods such as lemma, t-test, and ANOVA to examine differential gene expression between sample sets. The result table allows users to filter by gene, log-fold change, expression level, p-value, and adjusted p-value. The users can further create gene sets from the analyzed results for further analysis. With the sample sets defined and clinical attributes available, WebMeV also allows users to directly perform survival analysis between defined sample groups. WebMeV also have dashboard view where users can bring their analyzed results side by side for more convenient result visualization and examination. The next steps and the future direction for the MEV development is to first refine the clinical attribute selection interface, to construct framework for faster incorporations of public domain tools from bioconductor, gene pattern, and cytoscape. And we want to extend the data access to other large public domain data sets. And we will want to provide the ability to integrate analysis for cross comparisons of data sets. And lastly, but not least, we want to enable data and result sharing and discussion through cloud storage for collaboration.